Hi everyone. In this set of notes, we're going to go over chemical reaction rates and catalysts. So actually in this set of notes, we have two essential questions. The first one is what factors affect the rate of reaction? And the second one is how do catalysts speed up chemical reactions? So first we're going to talk about how chemical reactions happen. And so the model that we're using is something called the collision model. So in the collision model, it assumes that the only way that a chemical reaction can occur is if particles physically collide with each other. Okay? They have to physically collide with each other in a very specific way for a reaction to happen. And so the reactants have to be properly oriented. It has to be like a specific temperature, a specific condition for a reaction to happen. And so because of that, we have something called the activation energy, which is kind of this hump in our graph that shows the minimum amount of energy needed for a reaction to happen. And so for a reaction to happen, the two or more reactants have to get to a specific energy level in order for the reaction to happen and the products to be made. So things that can affect the rate of a reaction, one of them is temperature. If you guys remember from the first semester or earlier this year, the definition of temperature is the average kinetic energy of all of the particles in a substance. And so if a substance has a higher temperature, the particles in that substance have a higher kinetic energy, which means that they have more energy to collide with each other and create a reaction. Whereas substances with a lower temperature have less energy, and so they are less likely to collide and have a reaction. And so if we go back to our activation energy graphs, substances with a higher temperature have more energy, and so they're more likely to reach this point so that the product can form. Whereas reactants with a lower temperature need to get to a higher activation energy in order for the products to form. So substances with a higher temperature are more likely to happen. This graph is just showing that substances at a higher temperature, even more of them have a higher kinetic energy, and so more of them are likely to collide with each other and form the product. Whereas substances with a lower temperature, even though there's a lot of kinetic energy here, less of them have that needed kinetic energy to create the product that we want, and so less of them will collide with each other. Another factor that will affect the reaction rate is concentration. So if there are more particles, that means more of them are likely to collide with each other, and so more product will form. It's more likely that product will form. And so things with a higher concentration means more collisions, means more product. That's what this graph is showing here. The more concentration, the more likely, or the faster the rate of reaction. Okay. Another factor that affects reaction rate is surface area. So these are two scenarios, both of them where the blue particles are reacting with the red particles. However, in this first situation, all of the blue particles are put together in a block. So there's less surface area because there are less blue particles exposed to the red particles. Whereas in this situation, because the blue particles are separated, there's more surface area because more of the blue particles are exposed to the red particles. And so because there are the same number of blue and red particles in both of these examples, the same amount of product is formed. However, because there is more surface area in this one, this reaction will happen faster than this one. Because don't forget collision theory, the particles have to physically collide in a specific way for the reaction to happen. And so it takes longer for a red particle to collide with a blue particle here than it does for a red particle to collide with a blue particle here. And so this reaction happens faster than this one. But both of these reactions, because they have the same number of blue and red particles, they create the same amount of product. Okay, so that's all this is saying. Powdered magnesium reacts with acid faster than the same mass of magnesium in a solid mass. However, they both produce the same amount of product. These are more examples. So in this video, it's showing wheat flour that's spilling out, and you can see where the explosion starts and how fast that happened. If that wasn't in a powdered form, if that was a solid form, that reaction would happen a lot slower because there's less surface area. Here's another example of coffee creamer that's exploding. It happens super quickly because of all the little particles of coffee creamer. See another one of a dust explosion, then a sawdust explosion. Because all of these examples, all of these things, videos were in, all of the things that were exploding were in like a powder form, the reactions happen super quickly, and it's like a big burst of energy. Lastly, what we have are catalysts. And catalysts are things that speed up chemical reactions by lowering the activation energy that's needed for that reaction to occur. So remember, the activation energy is the energy needed for the particles to come in that exact way for them to collide with each other. And so normally, if in a reaction you need this is the reactants, if you need to go up to here for the products to get to a specific energy to react together, what a catalyst will do is it'll bring the activation energy from here to here. So you need a lot less energy for the reaction to occur. One example of a catalyst that everyone might be already familiar with is an enzyme, which everyone hopefully learned about in bio. Enzymes are really, really important to our body. They help us digest food. Normally, sugar burns at 700 degrees Celsius, which is insane. Our bodies would not survive at that temperature. So what we do instead is we have enzymes that bring the temperature of the reaction down to 37 degrees Celsius. And that way that reaction can happen and we can get that energy from burning sugar so we can use for our bodies. Two specific examples of enzymes. There's catalase that converts hydrogen peroxide into water and gas, oxygen gas, and that just brings the activation energy of this reaction down. So this reaction will still happen, just at a lower activation energy. And lactase, this is an enzyme that you are lacking if you are lactose intolerant like me. Do not have it. Sometimes you suffer anyway because ice cream is worth it. But this enzyme breaks down lactose. And so if you don't have it, you can't break down lactose. Then you're allergic to it. And then lastly, if you're familiar with these are catalytic converters in your car. And what they do is they take these three substances, which are very harmful, and they react them and make them into these three less harmful products. And so this is found in your car, and it helps with your car running. Yeah, I think that's it.